Good afternoon, everybody. Welcome to your last session. We are going to be watching Dangerous Hare, Hanging Attribute References, Hazards Due to Vendor Customization by Nan Zheng. And we are in South Seas GH. So a few more notes, but I'm not sure how valid they're going to be, being the last session. But stop by the Business Hall in Bayside AB. The Black Hat Arsenal is on Palm Foyer Level 3, and the Arsenal reception is at 5. If you haven't picked up your merchandise, today is your last chance to visit the Black Hat Swag and Bookstore. And I think they have a sale going on after this. And visit the Cali Linux Lab in Mandalay Bay A. Thank you for putting your phone on vibrate. It makes it easier for the rest of us to ignore the ringing while you wait for your voicemail to pick it up.
Hello everyone, welcome to my talk. So my name is Nan Zheng, a third-year PhD student and security researcher from Indiana University. Today I'm going to talk about a new threat brought by vendor customization, which we call it Dangerous Hare. Speaking of my lab, we are a group of researchers of System Security Lab. You can visit our website to learn more about us. Before diving into the problem, let me first talk about the Android customization. So for each new versions released by Google, hardware manufacturers like Qualcomm and device manufacturers like Samsung and LG will first modify to enrich its functionalities and tailor it to tailored into different devices. So this customization process continues when the device reaches carriers like Verizon, AT&T. They revise services or add in new apps to distinguish their phones or tablets from those of others. A study shows that only 18% of pre-installed apps of major smartphone vendors are from AOSP, which is the Android open source project from Google. Based on our study and previous works, we found that Android customization process is unregulated and decentralized, meaning every party is working on their own, no clear documentation to guide the process. Although Google launches an Android compatibility program, security problems could still arise when proper precautions have not been taken. One of the problems here is Hare flaw. Hare refers to hanging attribute references. The problem occurs when an attribute is used while the party defining it is missing, because it is removed during the vendor customization. And it is a new type of problem have never been investigated before. Here, Hare could be package names, activity names, and action names, as well as content providers and authority of content provider and permissions. Okay, here's an example. This is an abstract process of using an instant messaging app on a phone. So there are SMS and MMS, also a VIP content provider. So when an SMS is received, it'll be saved to the SMS content provider and broadcast to the instant messaging app, who will retrieve the content from the provider and display it to user. However, on a tablet version, the telephone service and the content providers are removed. The attribute of these content providers become hanging. Therefore, a malicious app could claim to be the missing content provider and inject fake messages to the instant messaging app, as well as get replies from the user. Some apps are aware of that the source they refer to might not exist in the system. So a safe way to do this is to check for its signature after checking for existence. Some apps will check system properties before invoking a non-existing app. However, not all hares can be protected by guards, which I'll show later in this talk. This is an example of a signature guard. It first acquired the signature of the package and verified before binding to a specific service. A wrong way to do this is to only check for existence. Remember that even if the package name exists in the system, it does not mean the app is protected, since the malicious app could easily define its package name and take its place. Here's an example of a property guard. So it checks if the device supports TV before invoking a special service, Google TV. Otherwise, it invokes YouTube instead. So during customization, if the vendor ensures that the property is enabled and Google TV is installed, it is safe. So hares are not random isolated bugs you could find anywhere else in Android. What causes problem here is the intrinsic interdependent relations between different Android components during the regulated Android customization process. Besides this, the party being invoked either does not verify or fails to verify the identity of the other party. So the developer thinks that if the attribute exists, it is okay, but actually it is not okay when the malicious app could easily take its place. I'll show you more examples, exploiting missing package, activity, and action names. S-Voice is a personal assistant service app pre-installed on some devices. One of its features is voice memo. So user can simply say take memo to take a voice note. After the note is taken, the app first checks if a system app memo exists in the system. If so, bind to it using action name and hand a note to it. Otherwise, it'll check if another system service S-memo exists and hand over there. On some devices, the memo app does not exist. Then the package name and action name used to bind to it to the service become hanging. A malicious app can take its place by using a package name and define a service with the action intent filter. So in this scenario, the voice note will be sent to the malicious app. Let's take a look at the video demo. So first, we can launch the S-Voice app. And the user can just simply say, take memo and the content of memo to record a voice memo. And in this test, we said, hello, this is a test. Then the voice app will notify the user that the voice memo has been saved. So by taking a look at the iCenote app, we can see the voice memo is saved in this app. Now we can install a malicious app. So our malicious app does not use any permissions. And by installing this app, it simply takes the package name and define a service to receive the voice memo. If you launch the S-Voice again and trying to record another voice memo, and in this test, we said this is a second test to distinguish from the first one. And then the S-Voice should say the voice note has been saved to the S-Note app. But actually, if you take a look at the S-Note app, the voice note is not there. It has been stolen by the malicious app who defines the memo package name. So we can also make it into a man-in-the-middle attack if we send the note to the S-Note app and the user will have no idea that all his voice note has been leaked. We have many demos here, so like faking Dropbox on LG and replacing official voice recorder, etc. And you can view Google sites Android Hare hunting for all the tech demos. Let's move to the next category, exploiting missing content provider. LG Cloud Hub is a system app that allows managing cloud accounts, uploading data to clouds, and accessing it from different devices. By default, it supports Dropbox and Box. It queries a content provider for additional services and adds to this page. Interestingly, on some devices, for example, on LG G3, this provider does not exist. When this happens, it becomes a Hare case where a malicious app can define its content provider and add item to the list, an LG cloud service. When the user clicks on the newly added item, an action add account will be sent. Since no app can handle this action either, the malicious app can define this intent filter and handle this action. So the malicious app can display a login page to steal user credentials. A trickier case is intent hijacking, which will attack Google email app and completely replace its internal account setting page with malicious activity. To invoke this activity, the app sends an implicit intent with an action added and data set to this URI. So these two parameters are specified in the account settings activity intent filter as shown here. If you try to define the same intent filter as this one in the malicious app, an intent truther will be displayed to user and let the user choose, which will expose our malicious app. However, during our analysis, we found that the authority of the content provider is hanging. No app defines it. Then the question becomes, how do we make the malicious app to be the only receiver by leveraging this? After carefully analyzing the logic of AMS, which is short for Activity Manager Service, we found a logic dealing with the intent resolution. It is a little bit complicated, so I'll use this diagram to explain. The AMS will first look for the MIME type of authority. So it'll check if the authority of this content provider exists. If no, the MIME type is ignored, and AMS will find the activity with same action at data field and invoke it. If yes, the AMS will get the type of authority and invoke the activity with same action data and the MIME type. Basically, it'll just invoke the activity with more matching fields. Since the content provider does not exist, a malicious app can define this content provider and when called, return a MIME type of its own, for example, ABC in this case. Then the AMS will try to find the activity with action as added, data field set to this content provider, and MIME type set to ABC. Guess what? The malicious app can define its intent filter as the original one, but with one more line, MIME type set to ABC, which makes the malicious activity the only one who will receive the intent. In this way, the intent from the app went only to the malware, leading the user to a malicious activity that lets her enter her password. Let's take a demo of this attack. So first, I'm going to show you we'll launch the Google email app. And if we click on the settings, it goes directly into the internal setting page. If we install the malicious app, which does not require any permissions, by installing the malicious app, it takes the content provider and when called, return a fake MIME type. So if you try to launch the Google email again and click on the settings, arrow goes directly into the activity that defined by the malicious app. You can notice it's different from the original one. So attacker can display arbitrary phishing page to user, and since it comes directly from the official app, user will most likely to believe anything it shows. In the last part, I'll show you how to exploiting missing permissions. One of the attacks it enables is service confusion attack. Some apps use multiple push messaging services, including Google Cloud Messaging, Amazon Device Messaging, and Nokia Notification. These services are used to push cloud messages to its receivers, and it uses system permissions defined by these services to protect them. For example, the Facebook app defines 3 receivers in this app to receive push messages from corresponding services. This gives them the advantage of maintaining one app and working on multiple brands of devices. However, most of Android devices only support one of such services. For example, on a Nexus device, only GCM exists on this device, and in this case, the ADM and the Nokia receivers are using a non-existing permission to protect themselves. A malicious app can define this permission and therefore owns this permission. it can send arbitrary message to the Nokia receiver, who will display the message to the user. The same will happen to Amazon phone by leveraging a GCM notification permission. Let's take a look at a Facebook service confusion demo. Let's first take a look at the attack app. It does not require any permissions. And then we can launch the attack app. Basically, it can send arbitrary message to any Facebook users. So in this test, we'll just send to a user we know, and the message will be fake message. If you click on the send, you will notice there are notifications showed up. And this notification is actually being sent by the Facebook app. So we can do this again, and it'll show up a fake message 1. So if we click on this notification, it goes directly into the Facebook app. And the message should be displayed in the conversation history, as shown here. So we can do this one more time, and by sending maybe a fake message too. So by launching this attack, the attacker could inject fake or phishing message to gain profit. So it showed up again. If we click on the notification, okay, the Facebook should update the latest message. It's shown here. That's right. So this Hare flaw also enables a message stealing attack. So on the Amazon Kindle device, a GCM service is not there. A malicious app can define GCM permission and push a registration ID to the Skype GCM receiver. Then what's the consequence of pushing a registration ID? Let's first take a look at the GCM setup process. So the first step is application registration, including acquiring a configuration file and set up app server, etc. Then the client app on the phone requires a unique registration ID, which will be sent to its GCM receiver. Once the app receives the ID, it will pass the ID to the app server and store it. The registration ID exchange in this process is the same client app instance identifier that the app server uses to send messages to the particular client. So after setup, when the app server has a message for this client, it will send the message to the GCM server and push it to its client. By leveraging the Hare flaw, an attacker can push his registration ID acquired legitimately from the Skype app to the victim GCM receiver. When the victim receives this, it will forcefully believe that the registration ID is sent by GCM and a GCM binding process is ongoing. Then it sends the attacker's ID to the app server and binds to the current user logged in on the victim device. The consequence is, when the app server has a message for the victim user, it sends the message to the GCM connection server with the attacker's registration ID. And of course, the GCM will send it to its attacker based on the registration ID. In this way, the attacker can steal all the messages sent to the victim user. Let's take a look at the Skype message stealing demo. So on the left-hand side is the attacker, and the right-hand side is the victim. In the middle is victim Skype friend. So the attack app, again, does not require any permissions. And if you launch the Skype app and send a message from the victim Skype friend by simply saying hello, the victim will receive the message. If you launch the attack app, it will push a registration ID to the Skype receiver and bind it to the attacker's registration ID. So now if we send a message from the victim Skype friend by saying hi, so the victim does not receive any message, and the message has been received by the attacker. And we found 400 apps have this Hare flaw, and 51 of them with more than 1 million downloads, including Facebook and Skype. So you can find more text at Google says perplexed message. And we have submitted some of the text to several app stores and like Google, Amazon, Samsung, and all of them are past the vetting process, which means it is very hard to detect such problem. And we remove them immediately after approval. We also reported our discovery to the vendors, and most of them have acknowledged and fixed the vulnerabilities. So after revealing these attacks, the next step, we build a tool to automatically detect such problems. The idea is to find all the occurrences of attribute references and to check if all of them are referred to existing attribute definitions. If one of them refers to a non-existing one, it is a case of Hare flaw. To implement this idea, we modified FlowJoid and underlying InfoFlow and Suite to support our need. We first take a factory image as input and extract APK and ODEX files. Since we need an APK file with code in it to do the analysis, we repackaged the code into APK file. And for Android and Lollipop and After, which use OAT files, we converted it to ODEX file and repackaged it to the APK the same way. Now we can go through the file and find the attribute references and attribute definitions to do a diff analysis. Remember that some cases can be protected by signature guards or property guards. So we conduct a taint analysis to detect such protections and do not report it as a Hare case. If you find a relation between the guard API and attribute reference API, we consider it as protected. Now, after property check and the taint analysis, we eliminate protected cases and report the rest as Hare cases. By using our tool, we scan 97 images that containing more than 24,000 pre-installed apps. We collect images from 5 vendors that cover 36 countries and 23 carriers. And on Android 4.x, we found more than 20,000 Hare cases in more than 3,000 apps. We don't have too much 5.x image at that time, but by taking a look at the percentage vulnerable apps, some remain the same. Some are at even higher percentage, more than 20%, and some have dropped. And we found that on a single device, there are as many as nearly 600 Hare vulnerabilities. That's really a lot. Before concluding my talk, I have some thoughts and suggestions to share. So each OS version is customized and recustomized by various parties, but little guidance has been provided to make sure that complicated relations among system components, apps introduced by different parties are being respected. In the absence of such guidance, Hare becomes inevitable. Moving forward, we believe that systematic efforts need to be made to eliminate Hare flaw. For example, secure each attribute reference by verifying the party involved, or document interdependent relations and make them open to the parties involved in OS customization and app development. And this talk is built upon 2 papers that we have published. You can find some of the material covered in the paper. And thank you for your time. I'm ready to take your questions.